Okay, so welcome everyone. My name is Madhuri Khan, and I'll be showing you my little mini game that I made using Unity. So basically, I use a tile set. This is the tile set, which this is an asset pack which I downloaded from the asset store of Unity. And next to the things, the scripts I made myself. There is this character here. So basically, what the point is that you have to collect cherries, and the cherries will be counted here. And if you touch the spikes, you die, and the game resets. So if I play this, and we can see it working in action. So you can see the characters moving. There's an ideal state, jump state, and then there's if you jump, you collect cherries, and if you touch the spikes, you respawn, and the cherry count is right over here. And you can keep counting on cherries, and if you touch the spikes, it resets the game. So this is a very small little game which I made. So yes, how did I make this? I've used the very standard Unity tools. First of all, you got the Unity animator, which is again you can see the ins and outgoings of each animation playing depending upon all the animations have to come back to ideal state from whatever wherever the thing is, and if it's that, it can be any state from the player that can be any state. Meanwhile, the jumping, running, and the falling states are part of ideal. It means that they have to eventually return to ideal state. So actually, all of them are connected to each other. I mean, all of them can go to ideal, all of them can go to running, all of them can go to falling. So since they're connected to each other, so basically, what these arrows mean is that these states can transition to this state. This arrow means this state can transition to this state, and this arrow means this state can transition to this state. And by state, I mean animation states. So, for instance, if I go to animation tab and I go to scene and I select the character, you can see we got different animations. The first one is ideal, and if I play this, you can see each frame of animation is playing. And if I stop this, if I go to different frames, uh, see the animation is playing right here. And suppose if I go to the player running animation, you can play this and you can see the player running animation here. So basically each of these animations are one state and they are connected to each other. So how this is working is that ideal player is going to be standing ideally, and this arrow means that the player ideal state can transition into player falling state, and this arrow from this direction means that player falling state can also transition to player ideal. Similarly, all of these are connected to each other, and which means that all of these states can occur simultaneously, which means that they can shift to each other very easily. So, and then we got any state is any state, and if you touch the spikes, that animation plays. So, if we play this, you will be able to see very clearly. So right now the ideal state is playing, and if I move, the running state plays, and then there's transitions back to player ideal state. And if I press the jump button, it turns into jump state, and then it transitions back to ideal state. Similarly, falling state, as you can see. And if we accidentally touch that spikes, it transitions to that state. So this is how the states are working, and cherries are being counted. All of them have a script here. If we go to Visual Studio, you can see we got the player movement script. Right now, first of all, we've included all the Unity system, Unity files, which we are going to be using, and then we are taking a class called player movement mono behavior, uh, and we have taken all the different properties of the object which we are trying to do. Serialize C, we got all the different properties such as rigid body, box collider, all that stuff. When we're starting, when the script is executed, this is the first function which runs, and we've got a jump count, and we are assigning all the variables to their respective components which we are getting. For instance, rigid body for RB, collider for box collider. Each of these variables will be then used throughout the code, and then we've got the update function, which is updating uh, each frame, and afterwards in this it's and then we got update animation function, basically in which we are actually taking float d. And if you see, the update animation function is called here, and what it's doing, it's actually taking directional coordinates and which we are supplying to this function. And based on this float value, all of these movement states are occurring. For instance, if flare is less than, if d, the state, if the direction coordinate state is less than, is greater than 0 float, then we go to the movement running state, and then we flip. And if we are going towards the other direction, we should be able to flip. It depends upon the direction. It depends upon the direction. So basically, yes, sprite flip basically means flip the sprite on towards x. Similarly, basically telling the coordinates, sorry, the direction of the sprite. Similarly, we are using different float values to make this movement happen. A running state, ideal state, all this different state, and we got similarly. So again, let me be clear again. Basically, update function is taking a float value, dirx. Basically, what it's doing is that it's taking the coordinates, the directions, points at which the character will be moving, and what it's doing is that it's updating animation based on those values. And then we got this last function. It is a bool. It is grounded. Basically, it's going to return a true or false value depending upon if the player is touching the ground. So suppose that if we jump, we want to land back on the ground, and then we will be able to jump again. It's not like we can jump on for infinite times, which was a problem which I've personally faced. So now it's fixed. So this right here is very basic uh, code for this, and this code is the property of sorry, the character. If we go to scenes, if we go to the character, we can actually see different properties which we have applied, and there is a script here. You can see nonce. There it is. It is the player movement script which we've attached to the player, so it's actually controlling everything, single thing here. Similarly, we've got a script for counting the cherries, and the cherry collection script, which if we look at this, so basically, again, it's a class. We have taken some parameters or properties of the object, and then basically it's been applied to the spikes, and basically what it's doing is that it's again, start function, taking all the components, and then we're going to use those components ahead. So basically, it's actually taking a 2D collider. So basically, when we collide with the object, we call the function die, and this is the void function. So basically, what it does is that it's actually sets the set trigger death, which we have given a tag over there. So this is how it's killing the player, and it's restarting the scene manager load window. Basically, it restarts the game. And then we got the item collection again. We have given a cherry count, and then uh, if we if the object collides with the tag cherry, which we have given to the cherries, we will destroy the object, and then which means that the object is collected, and we'll add into cherry count. And then we got the checks.carries, uh, which is the text. Cherry underscore text is basically the text which is right over here, and it is now being added to the cherry count. Okay, the cherry is written here. As you can see, it's going to be added to the count. It's actually a string, so basically string cherries is equal to cherry count, so whatever the cherry count will be. So this is how this is how this very basic game is working, a very basic game. Each script is being executed really well, and this is a small personal little project which I made. It took me about 3 to 4 hours because I was kind of new to Unity, and I'm still new to Unity, but this is the little project I've made so far. Thank you very much.